Next start our industrial talk that will be given by Jakub Kozák from the Datlowe company. He will be speaking about ontologies and combinations with text mining. And I give you my word.
Thank you, Peter, for a nice introduction. So my name is Jakub, and I am from a small company called Datlowe, or Datlowe, or whatever you pronounce it in English. And I want to present something about what we have been doing so far in the past 2 years and what we are doing now. It will be composed of 2 main parts. The first one is about our approach to text mining and how we are doing things. And the second one is a brief overview of use cases, what we have been doing so far. So, we are a small company, counting about 10 people now, established in 2014, and we are trying to deliver tailor-made solutions to large companies for text mining and data analytics. It means, what does it mean, tailor-made? It means that we carefully listen to the requirements of the clients and try to deliver exactly what they want based on their internal data. We are usually not working with internet-wide data or social media. We usually take data from our clients. It means emails with customers, internal notes, internal contracts, medical records, whatever. It will be shown in the second part of the presentation. So, why are we here? Also, we like to cooperate and collaborate with research. Most of us come from Charles University, and we are the graduates of Charles University, and we also collaborate with Peter here on developing some ontologies and discussing the topics that are in the middle of our interests. So, what do we mean by text mining? I don't know if everyone of you knows the meaning of these words, or what does it mean, that you may not be familiar with those two. We call it text mining or text analytics, and usually define it by a few examples. So first of all, we do text classification, which means you have emails from clients. You need to classify if it is a complaint, or if it is a request, or if it is just a suggestion how to improve your mobile application or something like that. That's the first task. Second one is topic extraction. It usually involves some general corpuses like news, detecting whether it's about sports, medicine, politics, or whatever. And the third one, which is the most important for us, is information extraction, which includes named entity recognition and relation extraction. And I will be talking about these 2 things most of the talk. When I use text analytics, I also mean, in a broader sense, predictive analysis, which is built on top of text later. It means, like, if you analyze clients' text, then you want to predict whether the clients will leave or stay within your company, and so on. So text analytics for us means also predictive analytics built on the top of extracted information and features from text. So, what we do, we try to combine natural language processing methods, I will explain later which ones, and domain dictionaries, ontologies, whatever we can call it. Usually, at this time, these are not very complicated ontologies. More or less, it's thesauri with some relations or rules built on top of it. What is our goal? These 2 things might be enough for text processing in our point of view. I believe that if you combine input text with a properly defined ontology and run it through some processing solution, you might get destructured information as the output. This is our ultimate goal. Just give us your input text, we will develop the ontology with all the dependencies and concepts and relations among them and put it into our solution and get the information extracted with all the relations involved in the text. We're not there yet, but we're trying to move forward to this larger and bigger goal. So, how do we proceed now? We have, this is like architecture, if very vague architecture. So we can work with inputs from databases, file systems, webs, or get the data from some APIs. It's not a big problem. I believe many of you can do this. And then run the data through our system, which includes NLP module with language models necessary. We mostly work with Czech, but we have been working with English, Polish, German, I think Spanish too, and have access to a large number of corpora which are necessary for proper NLP. Then we use the text annotation techniques, which takes an input delabels from ontologies and dictionaries that may be defined by ourselves, or they can also be downloaded from third parties, as today there is a lot of sources as open data or provided by academia as outputs of research grants and so on. So we do the NLP, then annotate the text, and at the end we try to extract the information. It means combination, it means disambiguation, combination of entities in the text, trying to extract relations, and so on. And we're trying to do this either by rule-based extraction or machine learning approach. The outputs are different. We can do it in relational database. We can also output RDF, because we use RDF for our ontologies definitions. We can output the annotated documents with nice colors everywhere. Usually clients like it when it has a lot of colors. And we can also build a search application with all the texts and extracted information as facets on the side, so you can search the texts with all these information extracted. So let's get into the first part of the processing. Just a simplified, very brief slide. What we do, it's based on technologies from Stanford or Charles University, or what is suitable for the specific task. We start with tokenization and sentence splitting. It means splitting two tokens. It's generally words, but it can be also a punctuation, blah, 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 and so more. We then do the morphological analysis, which is not that important in English, but is more important in inflective languages such as Czech, Russian, and so on. It means that we can detect part of speech, we can detect whether it's a present tense, past tense, whether it's a conditional, and so on. It's really useful for filtering only nouns or verbs or something when you're trying to index them in a search application or something like that. And it serves as a basis for lemmatization. Lemmatization means putting words in a basic form, which means we transform thought into think. Again, it's much more important for inflective languages like Czech and Russian and so on, than in English. Yes, so this is more or less, I believe, the classical things a lot of people are doing when trying to do NLP. But we don't think it's enough for proper information and relation extraction, and therefore we are trying to do also the last part of the natural language processing, and it means sentence parsing. So you can see on the right there is a tree built of the sentence below the tree. The client doesn't want our great credit card, and it clearly defines dependencies among words. It tells you what clauses you have in the sentence, that you have a subject, predicate, object. You can have also places and so on. It's really good for a lot of things. Just one for all, not described here. If you are doing some statistical analysis and using bigrams, it may not be enough to use only the word order in the sentence. Again, English, they have pretty tight rules how to write a sentence. In Czech, it's completely free. So we are not using bigrams by order in sentence, but we are using dependency bigrams, which means we are taking the words close to one another in the tree. So it means like client want, our card, credit card, and so on. So we are not using only the words that are in the order in the sentence. So we have these nice trees of sentences. We can have several levels of trees. This is the first one, and then we're trying to use these information for information extraction. So on the other side, we built domain models. This is a part, very simple, just for this presentation. Model, for example, for processing internal notes from some relationship managers in a bank. It means that there is a person, there is a product, and there is an organization, and either the person is interested or it is not interested in a product, and the product may be provided by some organization. So this structure and the structure of the sentence, the tree, can be combined together quite easily. So we are now trying to build our rules, some patterns that take the ontology dependencies and the sentence dependencies and combine them together. It means like we can have a person that is connected somehow to the product by a property which has a verb as its label. So it means person wants a product. Person doesn't want a product. Person is interested, is not interested. There's a whole bunch of verbs or properties you can have. And this relation, subject, predicate, object, as you may know from RDF, it's a basic names for the parts of the triple, is the same as the sentence structure. You have a subject, you have a predicate, and you have an object, which are mostly the most important structure. They usually carry all the information of a sentence. Let's have a small example on this familiar tree. The client doesn't want our great credit card. If we have this NLP, then we do the annotation by the dictionaries, and you can see we have client doesn't want, our, it means who is the provider, and credit card as a product. So easily we can have client doesn't want a card. It's the same pattern we have in the ontology, and it's the same pattern we have in the sentence. We combine them together, and that extracted relation between the product and the person. So as simple as that. Of course, it doesn't have to be so straightforward in the sentence. Usually, it's more complicated. This is more or less a demonstration case. So this is our approach. Let me briefly describe several use cases. I will try to be fast. You can always ask later in the lobby. It's not a problem. So, first of all, we have been working with several banks in Czech Republic, and usually they are working with structured data very well. They have large data warehouses. They're trying to do some predictive modeling and so on. But they haven't been working with unstructured data in the recent years very much. What is their usual goal? They want to keep the customer happy, they want to raise their profits, they want to acquire new customers, and so on. So we have, through the last 2 years, identified several sources of potentially valuable texts. First of all, notes from CRM systems about what the clients want, doesn't want. It means the notes that the relationship manager takes after the meeting with the client. Say he's wearing a jacket and he looks rich and he's a daughter and he doesn't want to travel anywhere and so on. All these information are hidden in the text and in the heads of the relationship managers, but the bank doesn't know about them. So you can extract it and give them information about the needs and wants and family members, products provided by competitors, because they also ask about, do you want mortgage? No, I have mortgage at GE, I don't want it. Okay, so they write it down, we can extract it quite easily. So this is the first use case. Then there is a large amount of incoming client messages through various channels, like emails, complaints, letters, whatever. Again, we have been doing some classification for automatic routing. It means like some people in a bank are working on specific types of complaints and so on, so we can direct the messages to them. And we also were extracting some important entities in the emails and detecting the so-called root causes. So what really made the client angry. Also, you can try to read their signatures. It's quite interesting that some people like to leave all their information in the footage of the email. For example, medical doctors, they're very famous for that. Lawyers too. So quite good to know. Then we have been also playing with some unstructured field in questionnaires, internet forums, and also social media, but very little. We have been trying to, for example, correlate the information in internet forums and news to complaints. There was a huge affair about fees to mortgages in Czech Republic, and the correlation was quite noticeable about when the news started to write about it, the clients started to complain about it. Okay, that was quite easy. So I will skip next 2 slides because it's just about the details about what I have already said. All these things can be used for predictive modeling, segmentation, micro-segmentation, and so on. Yes, this was an easy thing. This was an interesting thing. We were also trying to detect the style of writing of a person. If you have enough text from one person, you can try to detect how are they writing. Not about what are they writing, but how. It means, are they using a lot of verbs? Are they writing long sentences? Are they using foreign words? Yes, and so on and so on. We detected about 70 style features for each client, and then try to segment the clients, and it worked pretty well because it's a different point of view on the clients. It's not the demographic segmentation, it's completely different. You're trying to detect whether the people are using foreign words because they're trying to look smart, or they're acting to they're going directly to the point, or whatever. It can help you personalize the communication, detect the mistakes in the style of communication of the bank, and so on. Yes, here is a part of our model. I don't think it's that much important. It's about transactions. Just to let you know that we have something like that we have some types of transactions, we have some properties of transactions, and so on. I can show it to you later if you want. As I said, the results can be brought into a search application for end users. This is just a screenshot, so then you can search for clients that owns loan somewhere else. Okay. What did I do? Okay, it's not working. And you can also visualize the search results in the application. So I'm running out of time, so very quickly. Contract mining. In the last year, we have been very intensively working with large amounts of scanned documents from real estate industry. We have been extracting information from leases. Usually this is a huge amount of scanned documents. We need to use OCR. We are not developing OCR, we're using a third-party OCR. It's called ABI, or how is it pronounced in English, if you want to ask. We are using people for annotating the contracts, and we are also using them for extraction completion after the machine tries to extract the information. So the ultimate task for the client was to deliver high quality data with precision, targeting 100%, of course with combination with people, not just by the machine itself. And it was on the leases in the United Kingdom. So first of all, we classified the documents, because not all the documents are contracts. It can be amendments, it can be letters, it can be some invoices, and so on. So we need to split these documents into categories so the people can go through them quickly. And the second task was information extraction. It involves contract parties, lease term, termination option, prolongation, subject of the lease, rents, and so on. So we used a combination of machine learning methods and the rule-based methods to extract the information into structured fields in the application, which looks something like this. There is an OCR document. You can also view the original document. You can annotate things and link them to the information in the right pane, where we call it mini screens, but these are forms where the information can be put into the mini screens and corrected by the people. So we get the documents, we process it with OCR and some natural language processing, put it into the database, make it accessible in the application, fill the forms in the right hand, and there is a workflow. The people can work with the documents, complete the extraction, and then hand it to the client. They can also comment stuff and there's a lot of functions in there. Yes, and two last things. Currently, we're working with traffic collisions report for insurance companies because there are some new laws in Czech Republic, and I think it's also in the whole European Union, that the insurance companies need to quickly allocate money for indemnification of the participants of the traffic collisions. So they need to extract the key information very fast. So we get the reports and try to extract predefined set of information, types of injuries and their severity, whether there was some lethal injury, if there were some weak participants like cyclists, pedestrians and so on, and alcohol, drugs present. It's also important. There is, the list is about 10 major things, and we are trying to also provide the insurance companies with the detailed information. So it's current thing, and last but not least, we're doing some work in healthcare and in pharmacy. This thing was for a project called Drug Encyclopedia, and it was mostly an academic project of me and my colleagues at the Charles University, and we were combining several data sources together to have large database of drug-related data. And one of the things was to use unstructured data and extraction of drug-drug interactions and their types was a part of that work. Again, it's based on the sentence parsing and on the tectogrammatical trees, which is the highest level of parsing. And the last bullet, it's some simple rule that what you can have together or not in a sentence, and then if you have negation of discover, demonstrate or something, interaction, influence, inhibition, then you say there is it's not saying anything about again, pardon, it denies the potential interaction between these two things. We have been then applying these data source, integrated data sources to extraction of information from medical records, but it wouldn't fit in this so long presentation. Okay, so these are the use cases we have been working on. Last thing, we're always open for collaboration. As I said before, we already collaborate with colleagues from Charles University and from Czech Technical University, namely Peter here. And we would like to participate in any research projects, ideas, whatever you think might be interesting. So thank you for your attention, and if you have any questions, we can have maybe one or two now and later then by the stand.
Okay, thanks. So questions? Please.
Hello.
Hi.
I was wondering which NLP engines you are using, or have you developed your own?
NLP engines. We are using the NLP engines, as I said, from the Charles University, and for the framework we are using GATE. If you know, it's a general architecture for text engineering developed at Sheffield. It's a competitor to UIMAP presented before. Okay.
Which are medical ontology centers are you using? I mean, some standard platform you built.
Yes, we for the sake of this purpose, we have been using MESH, medical subject heading. We have been using National Drug File, which is some quite big ontology from the United States. And we also use drug bank.
Some papers also like UMLS, some mathematical language.
We haven't been working with UMLS so much because it's not translated into Czech, and that was the main problem, that we need a lot of things translated. So if we are working with English text, we would definitely use UMLS because it's, and Snowman of course, but it's but the problem is it's not translated. It's not translated now. So you're welcome.
Okay, any question?
How sophisticated are your ontologies? Are you using just RDFS? Are you using OWL? What level of OWL?
I think now they're not that much sophisticated. So we're using mainly RDFS, something from OWL, but I would say a little. The reason is simple, because we don't have time and the clients always push us to deliver it as fast as we can, so we do it as simple.
Okay.
Sorry. And what's the people store engine?
Usually we use Virtuoso, open source. Yes. And for internal, sorry?
They have an open source too.
Yes, they have open source. They have a community version. It's not that good as the professional version, but usually we use Virtuoso, or for just some debugging, I use Fuseki. It's Apache TBD or TDB? TDB with, yes.
Okay, any more? Actually, I have one. Jakub, you have introduced quite a lot of domains. I have sort of generic question. The development of the ontologies in the particular domains is a really challenging task. I just want to ask you, where do you feel, which domain is the most difficult as far as these that you introduce is concerned with respect to the communication to the experts, because you definitely have to get lots of information from the experts in order to construct it.
I think yes, it's a complicated question, but I think the most difficult environment for delivering these things and so on is healthcare in Czech Republic. Mm-hmm. It's really, I think, the most challenging to talk to medical doctors and try to make them help you and persuade them that this has sense and it may actually help them to do something and so on, because usually.
Okay, and regarding the stability and quality of the resulting model, does it differ between the domains, that you find out that some domains are really so dynamic that the model really changes a lot while the other not, or it is not the case?
I don't think so. It's quite stable for all. Legal contracts doesn't change at all. Banking, you have product, you have client, you have transactions. It also doesn't change so much over past 10 years. Maybe healthcare, there's a lot of new drugs and new things, but these are not the changes in the model. These are only changes in the underlying individuals in the concept.
Okay, thanks.
You're welcome.
So, if there are no more questions, thank you for your attention. We will close this session, and I would like to invite you for the afternoon session that starts at 2 p.m. At this point, I will show you some guide for restaurants.